Okay, today we're going to start a new topic, which is Java classes. And I'm going to begin with a motivating example. And then the very first Java class that we will look at will be the die class. Now, up to this point in time, we have, in fact, been writing Java classes, but we're going to look at a new type of Java class that differs substantially from the types of Java classes we've been writing so far. Okay, so let me start with a motivating example, and this requires us to kind of travel back in time to the early 1990s and the early days of the Java programming language. And let's pretend that the Java random class has not been written yet. Okay, so this is in the early days, random has not been written, and so we don't have access to it. Okay, so let's say that I need to write a Java program that simulates flipping a coin. Okay, in order to do that, I really need a random number generator, but random doesn't exist. Thankfully, though, I do remember that in homework 3, we have this equation here, and we can use this equation to generate a pseudo-random number. Okay, so here's my code. I wrote a class called coin flipper, and I have this next int method that takes in the 4 integers and computes the equation from homework 3. The result of this equation is a pseudo-random number between 0 and m minus 1, and that's what I'm returning back. In my main method, I say flipping a coin, and then I create my seed, A, C, and M, so I give values to those. Notice m is 2 because there's 2 outcomes. It's either heads or tails. I can then call the next int method, passing in my values, and the return value, what's returned is a pseudorandom number. It's either going to be 0 or 1. Okay, so then I have a set of conditionals here. If it's 0, I'll print heads. If it's 1, I'll print tails. And I do that a few times just to flip the coin a few times. Okay, so we can run this, see what we get, and there we go. Okay, so we flipped it 3 times, and each time we got heads. Okay, that's not bad. Let's say a little while later, then I want to write a Java program that deals a random playing card from a deck of cards. Okay, again, I need a random number generator. So probably the easiest thing to do is to just go to coin flipper and then like copy and paste that method, which is what I did. Okay, so here's my deal card class, and I have just copy and pasted the next int method from coin flipper. Here in my main method, I print out dealing a random card. I give some values to A, C, M. I set my seed to be 2. Notice here M is 13 because I'm going to generate a random face value, and there's kind of 13 possible face values that a playing card could have. So it's either an ace, a 2, a 3, a 4, 5, 6, so on and so forth, or a jack, queen, or king. So that's 13 values. Okay, so I call next int, I pass in these values, and out comes a pseudo random number in the range from 0 to 12. So I add 1 to it to shift it to the range 1 to 13. And then I just have a series of if-else if statements. So if the face value is between 2 and 10, just print it. Otherwise, we need to convert it to an ace, jack, queen, or king. Then I do the same thing, but now I set m equal to 4 to generate the random suit. So there's 4 suits. You can have clubs, hearts, spades, or diamonds. Okay, so I call next int. I get a pseudo random number between 0 and 3. And then again, I just have a series of if-else ifs to convert the integer into the actual suit. So clubs, hearts, spades, or diamonds. Okay, so we can run this. And there we go. Okay, so it generates a jack of diamonds. Okay, so that's pretty good, right? So let's say later on then I want to write code for a video game. And I'd like my computer players to be a little intelligent, not to do the same thing each time. So I need a random number generator. Okay, so I'm going to go to my flip coin class, open it up, copy the next int method, and use it. Let's say a little while later, then I want to write code to simulate some sort of biological or physical process, right? Maybe some sort of random walk or Monte Carlo, whatever. Again, I'm going to need a random number simulator, right? So I need to go to my flip coin class, open it up, copy and paste the next int method. Okay, so I'm going to do that again and again. And I've drawn a picture here that kind of just illustrates what my strategy is. Basically, for every class that I write, right, I'm going to go to the flip coin, open it up, and just copy and paste again and again and again the next int method. Okay, so my question to you is, why is this not a good approach? Okay, why is it not a good idea to continuously copy and paste the next int method? Okay, so I want you to take like a minute and try and come up with at least one idea. Why is this not a good approach to take? Okay, so I think it all boils down really to one thing, and that is repetition. Okay, so this is not a good idea because we have the next int method and we are repeatedly copying and pasting it again and again and again, 2 times, 5 times, 10 times. So if we were to one day realize that the next int method has a bug in it, we have in fact copy and pasted that bug, right? 1 time, 2 times, 5 times, 10 times. And now we have to go back over all of our code and look for every time we copy and pasted next int and go through and fix that bug. Okay, another reason that repetition is probably not a good idea, and this may be a more positive reason, is we could actually find a better equation for generating random numbers. I think from homework 3, we all realize this is a little bit of a crappy equation. Okay, so if we come across a better equation, again, I have to go through all of my code and I have to find every place I copy and pasted next int, and I need to update it with my new equation. Okay, so the more repetition we have, the more chance there is that I've replicated a bug, the more chance there is that I've generated more work for myself, and the more chance that there is that I overlooked a next int method and I didn't fix it or I didn't update it. Okay, so in general, repetition tends to be not good. Now, we actually encountered this problem before. So if you remember the tax helper class, in the tax helper class, we had a lot of repetition in our conditionals. In fact, oftentimes when we use conditionals, there's just a lot of repetition. So for the tax helper example, what we did is we pulled out the repetition and we made private methods. However, in that example, the repetition occurred inside of one class. And so we were able to do that. We were able to pull out the repetition and create a private method in that one class. Okay, the problem here, though, is that the repetition is happening across multiple classes. Okay, so it's not within a class, it's actually across multiple classes. And so the question becomes, how can we solve this problem, right? How do we eliminate this repetition when it's not occurring inside a single class, but across multiple classes? Okay, and the answer is this new type of Java class that we're going to be looking at. So really what we want to do is we want to take this next int method and pull it out of all the classes where we copy and pasted it. And we were going to create a new class. And I called my new class random number generator. And inside this new class, we will have the next int method. And now inside of flip coin or deal card or any of the other classes, we can create an object of type random number generator. And once we have that object, we can use the dot operator to call the next int method to get a random number. Okay, so basically we're going to pull out all of the repetition into a new type of class. Now, when we actually look at these new types of classes, one thing we're going to notice is that they don't have main methods. So you'll see in the random number generator class, in fact, there's no main method. And that's because this new type of class isn't meant to be executed. Instead, it's meant to be used inside of another class, like flip coin or deal card. And it's inside of that other class that we have a main method, okay? And the purpose of this new type of Java class is really to encapsulate some functionality and then we can use it inside of the other classes where we need that functionality. Okay. So this is what I've done. I created a class called random number generator. I'm just going to quickly scroll through so that you can look at the code. And you'll notice, in fact, there's no main method here. Actually, one of the other interesting things is I'm not using the static keyword either. Okay, I'm actually going to switch us away from the source code to the documentation. Okay, so I wrote this class called random number generator. And it has a constructor that takes the upper bound, which is m, and it takes a seed. And then it has a method called nextInt, and that returns back a pseudo random number. And I also wrote a method called reset, where you can give me a new seed, and it just resets the whole process with this new seed. Okay, so this is the class that I wrote. Okay, once we have random number generator, we can rewrite our coin flipper class. And now, instead of having this nextInt method and having all of these integer variables, right, all I need to do is create a new object of type random number generator. Okay, and I'm passing in 2 because that's my m. It has 2 possible outcomes, heads or tails, and my seed is 1. And then from that point on, all I have to do is say rng.nextInt, and that gives me back my random integer. Okay. Similarly, I can rewrite the better deal card class. So here I have 2 random number generators. I have one for the face value that has an upper bound of 13. There's 13 possible outcomes. And I have one for the suit, right? I passed in 4, and it has 4 possible outcomes for the suit. Once I've created these random number generators, all I need to do is just call the nextInt method. Okay, so I call nextInt to get my face value, and then here's my set of conditionals. And then I call nextInt again to get my suit. And again, here's my set of code statements. Okay, so that's what the code would look like if we wrote our random number generator class. Okay, so we're going to, in this lecture, we're going to look at this new type of Java class. We're actually not going to focus on the random number generator class because it's a little too simple and it doesn't illustrate all of the concepts I want it to. So instead, we're going to be looking at the die class. And my goal for this lecture, we're not going to look at any code inside of the die class, but instead, we're going to kind of talk about a high level understanding of what this new type of Java class is and how does this new type of Java class work? How does it function? Then in the next lecture, we'll actually be opening up the die class. We'll look inside at all the code, and there's a lot of new syntax that we'll be learning. Okay, we've already seen the die class. We looked at the die class when we talked about memory versus state equality. So this is a class that I wrote. It simulates an n-sided die. And as we'll see in the next lecture, there's no main method inside, right? Because this die class is not meant to be executed. It's meant to be used inside another class. And that other class has a main method. Okay, instead, the die class encapsulates some functionality, which is a die, right? Simulating the role of a die. It encapsulates some functionality for us to use in other classes. Okay, so here's a drawing that I came up with, I'm very proud of. And what this drawing is showing you is it's showing you the high level organization of this die class. In the next lecture, when we open up the code, we'll actually see that this drawing corresponds to the code that's inside the die class. So I'm just going to kind of take you through this. And again, the goal is for you to kind of get a good intuition or kind of a general understanding of this new type of class. Okay, so when we open up the die class, we're going to see that all of the code inside relates to one of 2 things, either data or methods. Okay, so inside the die class, we will have variables, and these variables will be unique in that they're not declared inside of a method. Instead, they're declared inside the class, but not inside any particular method. what that means is that these variables have scope, or I guess the scope of these variables is the entire class. In particular, the die class, you'll see that we have two variables. I have one variable to store the face value of the die, and another variable will be a random number generator to simulate the rolling of the die. These two variables here store or capture the state of the die. Okay, so at any given point in time, the die is existing in some state. And that state really, because it's a die, really it's just summarized by the face value. Okay, so I roll the die, sometimes I get a 3, sometimes I get a 1, a 6, a 4, a 2, a 3, whatever. Okay, so these variables here are capturing or storing the current state of the die. The other thing that we'll see is that we have methods. And I'm only showing 2 of the methods. In fact, the die class has a lot of methods. So let me just open that up. Here is my die class, and I'm going to toggle over to the documentation. So this is the documentation. Again, we looked at this in a previous lecture, and the die class, I created 2 different ways that you can create a die object, and I have a bunch of methods in there. In my drawing, I'm just showing 2 of those methods. I'm showing the roll method and the get face value method. Okay, so inside the die class, we have these 2 methods. They're public methods. The roll method just gets a random integer, right, between 1 and, I guess, between 0 and 5. And then it adds 1 to it so that it's between 1 and 6. And then it stores that in the face value. The get face value method is even simpler. The get face value literally just returns back the face value so that you can access them. So you'll notice that because the variables are declared at the class level, every method in the class can change those variables, and every method can access and return those variables. Okay, so that's kind of the benefit of having your variables declared at the class level. Every method is able to access, and every method is able to change. Now, from outside the die class, right, if we wanted to create an object of type die, from outside the die class, all that we know about are the public methods, okay? And the public methods together are known as the public interface. So this here, this web page is showing the public interface of the die class. And for the users of the die class, meaning anytime we write code where we're creating a die, like die d1 equals new die, right? We're using the die class. We only have access to the public interface. Okay, so that's why on the outside of the die, the only thing that shows up are these public methods. But there may be private methods inside, and we'll see that these variables are private. From the outside, when you're using the die class, though, all you have access to are these public methods. So let's say that we wanted to write a piece of code just like we did in a previous lecture where we created some die and we rolled them. Maybe we're implementing a game. We have access to these public methods, and we can call these methods in any order that we want. It's kind of like a vending machine. You just get to choose the method. So maybe I'll create a die and then I want to roll it, and then I get its face value just to check. And then I'm going to roll it maybe 5 times and then stop and get the face value again, and then roll it a few more times and stop and get the face value. So when we use the die class, we can call the public methods in any order that we want to call them. Okay, so that's basically a high-level understanding of this new type of Java class, and looking specifically at the die class. There's kind of the inside of the die class where we have the variables and the methods, and then there's actually using the die class, and that's the public interface, and we can call any of the public methods in any order that we want. Okay, so how do we use the die class? We've already seen this. So once we have the die class, once it's written, then we can do things like we can say die, oops, that should be capitalized. We can say die D1 equals new die. And when we do this, we're creating a new die object. Okay, so this die class is the blueprint. From this blueprint, we create a new die object. This die object has its own set of these variables. So it has its own face value. And I think in my code, at least, the face value starts off as 1. It has its own random number generator. This is actually an object, right? It's an object of type random. So it's sitting somewhere in memory. Let's say it's sitting at address 1200. And then this object has its own, roll method, and so on and so forth. If we were to create a second die D2 equals new die. Again, the computer uses the die class as a blueprint for constructing, right, this new die. This new die has its own set of variables, so it has its own face value. It has its own random number generator, maybe sitting at address 1400. It has its own roll method, so on and so forth. So every time we create a new die object, the class acts as a blueprint from which we create the object, and each object has its own set of variables and its own set of the methods. If I was to say d2.roll, then right, we would update the face value, maybe we roll to 4. So now the state of D2 is 4, it has a face value of 4, and the state of D1 is 1, it has a face value of 1. Okay, so basically I'm just saying each of these objects has its own state represented by its own set of variables. Last but not least, I've said this a few times, but I did want to just write it out. A class, by which I mean this new type of Java class, is a blueprint from which objects are created. Okay, so a class is a blueprint from which objects are created. And I don't mean that figuratively, I mean that literally, like literally, we will see that when we write this new type of Java class, we are in fact writing a blueprint. And that blueprint is used every time someone creates an object from our class. And that's that. Okay, so that's that. In the next lecture then, I'm going to be opening up the die class and we will be stepping through line by line. And we're going to kind of take this intuition, this kind of picture, and we're going to ground it in actual code. And we'll see that there's a lot of new syntax that we need to learn. Okay, so let's kind of go back to the beginning. So you should understand and be able to state in your own words, what was the motivation for developing this new type of Java class? In particular, what was the problem that we were running into that prompted this new type of Java class? And that's kind of summarized in this picture here. The die class, we're going to be sitting here for a little bit and just really looking at the die class and using it as kind of our first example and pulling it apart. We'll see that it doesn't have a main method. It's not meant to be executed. Instead, the die class is meant to be used inside another class because the die class, it encapsulates some functionality, just like my random number generator class did it. It encapsulated some useful functionality, and then we use that in these other classes. You should also be able, in your own words, to describe what this picture is and what the different parts are and how things are working together, both the data and the methods, but also kind of the stuff inside the class versus the stuff that we can access outside of the class. And that's one of the questions for the in-class problems is, in your own words, describe what this picture is displaying. Last but not least, once we have the class, we can use it as a blueprint from which we create objects, and each of those objects has its own state represented by its own set of variables. And in general, a class is truly a blueprint from which objects are created. Okay, that is that. And you can see the code, the BlueJ code posted to our Canvas webpage if you want to look at that more in depth. Okay, and I think we are done.